everyone, welcome back to SAT Math Question of the Day. Here's our question. Please try it. Pause the video, come back, and we'll go over it. Okay, line K is shown in the XY plane. Line J not shown is perpendicular to line K. What's the slope of line J? So, it seems like an extremely straightforward problem, and it's not a multiple choice problem. So, line J is going to be perpendicular, which means it's going to be like that. And we know that the two lines that are perpendicular, their slopes, m1 times m2 is -1, or the slopes are negative reciprocals of each other. So we need to figure out what the slope of line K is. And the slope is rise over run. So we figure it goes up. Now it's negative. It's a negative slope. It's down 2, but over 1, 2, 3, 4. So it's 2 over 4, which is -1/2. So the slope, the answer to our question is 2, because the negative reciprocal of -1/2 is 2, or -1/2 times m2 is -1. We solve for m2, and it turns out to be +2. Very straightforward problem. But you do have to know how to calculate the slope of a line, and you do have to know what the relationship is of the slopes of are of perpendicular lines. So, what do you think, Seth?
Yeah, sounds good.
Yeah, pretty standard. So should we get right?
So the problem, you solve the problem by applying a couple of facts. The key fact is that when lines are perpendicular, their slopes are negative reciprocals of one another.
Right. Yeah, you need to know that. You need to know that to do the problem. Yeah.
So we talk about why it's true?
Sure. Yeah, let's talk about why it's true. Absolutely.
Why is it true?
It would be a good idea. But why do we even ask that question? Because if you know something, or you even memorize it, it's better. It'll stick more if you understand why it's true. There's more of a chance you'll remember it, and you'll appreciate it more. So, yes, tell us why. I was going to ask you, actually, why is it true? Can you prove
Well,
it?
what does it mean to be perpendicular?
Yeah.
The explanation depends on where your starting point in the definitions. But you could look at this way. I drew in the red triangle because it's so easy to use the axes as part of the triangle.
Right.
And then the perpendicular, to consider the line that's perpendicular, you just rotate that triangle by 90 degrees.
Right. Yeah.
And what happens is the two sides, the sides get interchanged. So if I turn it by 90 degrees, what I'd get is this triangle. See? Take this triangle and rotate it, say, to the right 90 degrees.
Yeah.
And then, of course, the hypotenuse is black.
Right.
Yeah.
The hypotenuse.
So what happens? What happens is, well, let's see. Both of these.
The rise and the run switch places.
And the rise and the run switch.
The algebraic sign of the slope also changes. The slope changes from a negative slope here to a positive slope here.
Yeah.
So
Yeah.
the algebraic sign changes, and the x and the y flip, which is
Yeah.
now we really see why the x and the y flip. You can really see it
Yeah.
visually. But what about that? We just waved our hands and said the algebraic sign of the slope changes. But we didn't really justify it, did we? Not really. We just looked at it and said, as seen on diagram, which I always think is a flaky way to argue something in math. Like, to say this is the way it looks that way. Because maybe they'd only look that way for this example. Uh-oh,
Okay.
Seth is thinking, not a good sign.
Well, think of rise over run. We go from point. We start at the origin is A, and we go in the negative direction.
Okay.
And as we go in the negative direction, the change in the height is actually positive. Say call this point, say A. Let's call this point A prime. We start at A on the x-axis, and then A prime is the point on the line where x equals 0. And then we move point A over to here to point B. And then A prime moves up because A prime moves into point B. So our run is negative and our rise is positive. Now here, the run is positive as before, but the rise is also positive.
Yeah, right.
But here, the rise was positive and the run was negative.
Yeah. Yeah.
Which gives rise. So in this case, the slope is negative. In this case, the slope is positive.
Okay.
So what happens is, one of the rises and the runs flip sign. When you interchange rise and run, one of them changes sign and the other one doesn't change sign.
Right.
I guess that's how it works. When you rotate this triangle, one of the displacements goes the other way. Like if you wrote the long displacement changes from a negative to a positive, and the short changes from a positive. This is positive here to positive.
Okay.
That's the explanation that
I think we're just
that applies to this example.
Right. Yeah. Just applies to the example. Okay. We don't really know.
Yeah.
We're giving very poor answers here.
Yeah.
We're really.
However, I think in a more advanced mathematics subject, they would introduce the dot product.
Yeah,
for defining what perpendicular means.
Right.
And then it shows from algebra.
Yeah. You could always tell when people are just basically not knowing what they're talking about, and that's us right now. So we should just move on.
Yeah.
Okay, so but as far as taking,
and then, however, another heuristic is that is that you wrote you could imagine in this example, uh, like this you take take a generic pair of perpendicular perpendicular line perpendicular lines, right? And oh, okay, generic pair of perpendicular lines, right? And then consider, say, a vertical through them, right?
Right.
And so the you could see from this diagram that the slopes have opposite signs.
Yeah. Right. Yeah. So it
Yeah,
has,
yeah, from that.
Right. So
Yeah,
that's an intuitive approach. By the way, we
yeah.
forgot one.
Except in the case of, I think it's a degenerate case where
Yeah, well, I was just going to mention that.
where one of the lines has infinite slope.
Right.
In
Yeah.
other words, it's vertical.
We're talking horizontal and vertical lines. So this is
Yeah.
true. This is true, except, until this was a mistake in being precise, because we said it's true. It's not always true, except when lines are vertical and horizontal. Right. Now we just know in case of vertical and horizontal that they are perpendicular. Vertical and horizontal lines are perpendicular. So, or a line perpendicular to a vertical line is a horizontal line, and a line perpendicular to a horizontal line is a vertical line. And don't deal with the slopes. Just say that those lines are perpendicular. Okay, so I think we're done. But okay, so let's ask the big questions. Calculator. First of all, this was not on a calculator section. This is an old test. Back in October 23, there was a non-calculator section. This was on a non-calculator section. The new test has no non-calculator sections. Calculator always. Calculator here wouldn't really help. No, it would make no sense to graph that line over. Forget it. Would this?
I don't know. It's pretty silly to use a calculator.
Yeah, okay, we're done with that. Okay.
No, but you might use a calculator. You take the slope as what, minus a half, and put it in the calculator and say minus a half. Then take inverse minus a half raised to the minus one power multiplied by minus one. You might use a calculator for that.
Yeah, I mean, some calculators.
But that is abusing a calculator.
Right.
It's
So forget. Yeah, this doesn't make sense. Okay, is this question different? Would you do this question differently from school? In other words, sometimes you do SAT questions differently from the way you do them in school. I don't think so. I mean, if you had this question in school, you do it the same way. Plus, it's not multiple choice.
Well, in school, they often ask you to show your work.
Yeah. So yeah. And then, start with a guess. Well, that doesn't apply. It's not a multiple choice question. And what's the main idea of the question? The main idea of the question is that, well, we already talked about it. You need to know what the relationship of perpendicular lines, the slope of perpendicular lines, which you already said, and you also have to know how to calculate the slope of a line from a graph. So we already talked about the main idea of the questions. Okay. I think that's it, right? Yeah, that's it. Okay, so we're going to move into Throwback Thursday now. So we'll just move into Throwback Thursday, and then we'll do our introductions. So today is Throwback Thursday, which means we go back to a test from the SAT test from maybe 20 years ago, 25 years ago, to see how it feels different. Some of the questions are the same, but some of the questions are different. We only choose the questions that feel different. So here we have a question from a review book from the SAT people, and here we go. I don't think you'd see this question on a post-2016 test, when the tests were reflected more what you did in school as opposed to just whatever you smart, until more of an intelligence test. Okay, here we go. P is the set of positive factors of 20, and Q is the set of positive factors of 12. Aha. If X is a member of set P and Y is a member of set Q, what is the greatest possible value of X minus Y? Well, it's good that they're both positive, so that makes it easy. And greatest, so it doesn't that make, wouldn't we want x to be as big as possible and y to be as small as possible? Wouldn't that
Yeah.
seem to make sense?
Yeah. Yeah.
Yeah. So we're looking for the biggest value of x, and x is a member of P. So what's the biggest factor of 20? Isn't that 20?
Yeah.
And what's the smallest positive factor of 12? Isn't that 1?
Yeah.
So then it would be 19. Wow, I actually was able to do it.
Yeah.
Yeah. This seems like a question they wouldn't ask now. Because it's not usually a thing you do in school. It's more like a number theory question, isn't it?
Yeah. Yeah.
Yeah, you have to know. We're not going to go through the whole thing about what you need to
I
know.
noticed they do not give you a choice of 17
Okay.
because one, I think in more advanced mathematics, one is not considered to be a factor of anything.
Really? What about 20 though, or 12?
20 is a factor, but so when you factor a number, well, yes, it's
I mean, if 20 is a factor,
well, one is not considered a prime number,
right?
and therefore, because you want unique factorization into primes.
But this is not unique.
So it's unclear whether we should consider always one to be a factor of a number.
Well, maybe that's.
But if one is not considered to be a factor, then the smallest factor of 12, the smallest factor of 12 is 2. Right. So the smallest factor of 12 is 2. The largest factor of 20 is 20. So notice they didn't give a choice for 18 either.
Maybe
if they gave 18, then one could argue that 18, if you take factors, if you don't consider one to be a factor, then 18 is the answer. But they don't give a choice for 18.
Right, so maybe they did that purposely.
Yeah,
maybe they didn't want ambiguity.
Yeah.
Okay, so I think we're done. Wow, this was we got away.
So it's a question about reading the English.
Yeah.
Interpreting the meaning and figuring it out.
Well, right, because you also have to. This is classic about the greatest possible value, and knowing that this number y then has to be the smallest. If you want the greatest possible number, you want the smallest thing that you're subtracting from x.
Yeah.
Similarly, if you want the
another feature of this problem, it tests your ability to keep track of P and 20 and X. So to keep track of, so see, P is what connects the possible values of X to the number 20. So you have to, and then the question is the difference is X minus Y. It would be different if the question were Y minus X.
Yeah, of course, yeah.
So you have to keep track of 4 symbols and 2 numbers.
Yeah.
Yeah.
And then sometimes you get a variation of this. If the numerator, if they're both positive, then The smaller the denominator, the larger the number.
Yeah.
So the smaller the number you're subtracting, the larger the number. The smaller the denominator, as long as they're both positive,
Yeah.
leads to the larger number. So that's an important thing that you need to
So
remember.
this is also it's a test of the students' fluency with the language of sets and properties.
Yeah.
You could reformulate this problem in a way that's much more direct without talking about sets.
Right.
You could say, uh, if X is one of the positive factors of 20, and Y is one of the positive factors of 12, what is the greatest possible value of X minus Y?
Right. That's right. So they're bringing that thing in. Yeah. So that people don't get. Yeah. Okay.
So the test of it is two. So the two parts of the test. One is solving that problem about X and Y. And the first is figuring out that this problem with the P's and the sets and the Q's and all that set stuff is really the problem about picking X and Y, so X is a factor of 20 and Y is a factor of 12, and you want to maximize X minus 1.
Right, so it's asked in sort of an obtuse way.
Yeah, it's a two phase problem. Yeah.
Okay, so I think we're done. Let's just introduce ourselves. I'm Joel. I have a PhD in mechanical engineering, and my brother Seth is a PhD in math from MIT. He's been teaching computer science for many years at SUNY Albany. He's now retired. We're here to hopefully offer ways to approach SAT math questions. Hopefully, we have different approaches. We have different lenses. We see the questions different ways. We look at different ways to do the problem and offer those. The one we just did before seemed to be there weren't a whole lot of different ways to do it. But that's what we do. In terms of studying, try to take as many practice questions as you can and focus on the questions you're weak on. Focus on the topics you're weak on and go to Khan Academy. They offer targeted practice for different topics. So practice on the topics you're weak on. Also, practice on the topics you're strong on so you don't make any stupid mistakes, because sometimes they have these little traps they put on the, in fact, not sometimes. They always put one or two questions, little traps, so be careful of those. If you do enough questions, you'll see you'll be caught on a few. And I think that's it. So then please dislike. Please give us comments on our videos. More people have been giving comments recently, so thank you very much for that. That's really appreciated. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Okay, everyone, have a great...
The email address is in the YouTube page.
Yes.
For our channel.
Yes, that's right. If I said it too fast, that's right. Okay. So I guess that's it for Throwback Thursday. And then hopefully have a good Thursday. Take care, everyone.
Well, okay.